Hey, hello. Good afternoon, everyone. Thank you for coming to the last session of the conference. This is building Metro-style apps with HTML and JavaScript. My name is Paul Gus Marino. I'm a PM lead on the UI platform team on Windows 8. And my team delivers a lot of the features that we've added to HTML and CSS and the Windows library for JavaScript that we've made to help you make Metro-style apps with HTML and JavaScript. I've been at Microsoft for 10 years now, working on UI technologies the whole time. The past 3 years working on Windows 8 UI platform. And before that, I worked on the Windows Shell team, and I was responsible for a lot of the features of Windows Explorer that you see in Windows 7 today, if you use Windows 7. Just to give me a sense of who's in the audience, how many of you have actually installed Windows 8 on some computer and actually played with it with your own hands? Okay, good number of you. How many of you tried writing an app yet, a Metro-style app? You've opened up VS and created a new project and stuff. Okay, a few of you. How many of you actually tried doing so with HTML and JavaScript? So an HTML and JavaScript app, Metro-style app. Okay, good. So a few of you have actually gotten your hands wet in this topic. Today's talk is going to be all about Metro-style UI and how to build it with HTML and JavaScript. It's going to focus on the UI of the application itself. So there was a talk the other day that Scott Dickens gave that talked about the app model overall. And so I'm not going to cover that material. You should see that video if you just want to understand the overall app model for the Metro-style apps with HTML. We're really going to talk about the Metro-style UI itself and how to create that in HTML and JavaScript and the features and things we've done for that. We're going to dive especially into kind of an overview of the platform and then especially into the features in HTML and CSS and the features of the Windows library for JavaScript. And you'll leave with a lot of tangible examples of specific things you can go and take advantage of in making these applications. There's actually going to be a surprising amount of material we're going to cover, so kind of pay attention. I'll try to speak fast but clearly to get through it all. So let's start with what is Metro-style UI. And I gave a talk earlier today that kind of goes into a lot of depth about how to think about it. But for the most part, it's not just a skin you apply over your existing UI, but really a Metro-style UI is a set of patterns of the user experience that people become familiar with using. Patterns like, where do I go look to find commands, and what are the keyboard shortcuts for them, and how does it feel when I pan stuff, and how do I select things, and how do things fit on different size screens. All these patterns that users come to appreciate about how the UI works and looks that creates an environment for them that they're familiar with. And so that's really what Metro-style UI is about. And it's grounded in a set of principles. Principles like pride in craftsmanship, fast and fluid, do more with less. And I'll talk about how these patterns and how the platform features we've built enable you to exhibit those principles in the UI that you create. And it's supported by the Windows 8 platform. And so everything I'm going to talk about today are new features in Windows 8 that we've added to the platform so that you can create these Metro-style UIs. People sometimes ask me, can I create a Metro-style UI in Windows 7? And we don't think so because we tried to, and we found we had to add all these features I'm going to talk to you today about in order for us to do that. So Windows 8 was the outcome of us creating all these platform features we felt we needed to have in order to build Metro-style UIs. And so that's what we're going to focus on learning about today. And I'm going to start with a demo just to kind of show you what we're talking about here. And so I have a few apps I want to show. And all the apps I'm going to show today in the demonstrations are publicly available apps that you can get if you install the Windows 8 release preview. I don't have any special secret apps I made just for this demo. I'm making all the apps ones you can go and use yourself. And so the first one is just one I found. This isn't one that Microsoft made or anything. I just found this app on the App Store, but I thought it did a good job of using the platform features and showing Metro-style UI, and it's an HTML app. And so the first thing you see here is you launch the app. It takes up the full screen. It's a very immersive experience. It has this adaptive layout to it. And it has this grid view, and I can pan this grid view. I can mouse over items, and you see that there's a built-in hover effect. I can tab and arrow around, and you can see you can arrow around with the keyboard. I can use the mouse to scroll. I can use the scroll wheel on my mouse to scroll, and so forth. There's a whole experience around kind of how this grid is presented and how it works. This is actually using the HTML list view control. It's one of the controls in the Win.js library, and I'll be talking about that today. Another thing, and it's a very common thing you see across Metro-style apps. Another thing you'll see in this application is if I swipe from the bottom, I get an app bar. So I'll do that again for you. But if I swipe up from the bottom, an app bar comes up. That's another common control and another common pattern of Metro-style UI is the app bar control. That's also in Win.js, and I'll talk about that. You'll see if I navigate around in the application, there's a long list of information here. And so this app also uses something called semantic zoom. That's another feature of Metro-style UI that's very common, where you can pinch out to see a larger view of your content, and then you can pinch in to get right into a story. So semantic zoom is another thing that's in Windows Library for JavaScript. I'm actually not going to dive into that API, but once you see the other ones, you'll have an understanding about how to use other controls that are part of Win.js, like semantic zoom. In this app, you'll also see that it's all based on inline navigation. And so it's a single-page application. There isn't pop-up windows. There isn't navigating to whole new HTML files. Everything is done inline there. And I'm going to talk about that and the features we put in for that, as well as how the animations come in very smoothly. So as you navigate in and out, you see these smooth animations. And we'll talk about how those are done. So this is one example of a Metro-style app that exhibits a lot of these features, these fast and fluid animations, this grid layout, this app bar, and so forth. Another app I'm going to show you is the SkyDrive app. This is another app that also shows a lot of these common patterns. There's a grid here. I can go into a folder in here, and I can select items. So how selection works, that's something that's provided for you using the controls. And I can do things like delete an item. I can delete these two pictures here. This is talking to data on a web service, updated the data, deleted, you got an animation. So this is another aspect of Metro-style UI. These fast and fluid animations that you get when you delete items and so forth. I'm going to talk about the animation library and the controls that give you this, and how you can connect to data that's on web services or other forms of data and show it in your applications. So this is just a kind of preview of some of the kinds of Metro-style apps you'll see. Again, those smooth animations. A final app I'm going to just show you right here is the Mail app. This is also a Metro-style UI. It's not a horizontally scrolling app like the other ones, but it's still Metro-style UI. It also, again, uses a list view. You can select things. You get the app bar. You have inline navigation. You have smooth animations as you do things. There's a little delete animation and so forth. And all three of these apps that I showed you were all built entirely in HTML, CSS, and JavaScript, all the UI of them. And so now let's go back to our deck with that kind of overview about Metro-style UI, those different patterns, and so forth. And let's dig into the platform itself. So what is the platform that you use to build these UIs that have these kinds of controls, these kinds of animations, this kind of inline navigation, and so forth? Well, really, there are three families of APIs you're going to be calling into to create the UI of your application. At the center of it all is HTML and CSS. All the HTML and CSS APIs that you know, divs and canvas and attributes and all the CSS properties you know about, that's the core set of APIs that you're already using today if you're doing web development and have a website or a web app. That's the core family of APIs you're going to be using to build your application. In addition, there's something called Win.js, or the Windows Library for JavaScript. This is a new JavaScript library that Microsoft has created to give you even more capabilities and more controls and things that we felt you needed to have to create Metro-style apps. And in addition, there's the Windows Runtime APIs. And those are the core Windows APIs that you can call into to access the system and system capabilities. Let's dig into each of these a little bit more. So HTML, CSS. We all know this is a powerful engine for presenting data and user interfaces. We can all name companies worth billions of dollars and euros who build all their UI in HTML and CSS. It's a very, very powerful technology, very, very powerful family of APIs for creating very rich user interfaces and presentations of data. Another thing about HTML and CSS that's very relevant is that it's widely used everywhere. So all of us probably have skills in using it, or know people have skills, tools, code libraries that already exist. And so you can use all those skills, all those tools, and all those existing code libraries to make your Metro-style app in HTML and JavaScript. If you have some JavaScript library of charting controls or something that you like, you can go ahead and use that, because it's all built on top of that same HTML and CSS engine. And for Windows 8, we looked at the HTML and CSS engine that we had, and we found that there's some things we had to add to it so that you could really build Metro-style UIs. And so we extended it with additional capabilities that are required. In some cases, improving our implementation of existing standards. In some cases, implementing new standards that we hadn't yet implemented before. And in some cases, augmenting standards with even more stuff. And so I'm going to dig into those in more depth in a bit. Now, for some things, we found it didn't make sense to extend HTML. and CSS, it made sense to provide that functionality in JavaScript to you. And so we actually created a JavaScript library. Our Windows developers, if you can believe it, got together and we built a JavaScript library. And it really comprises three main pieces. First is it has a set of UI controls and other building blocks for creating the UI, things like the list view, the semantic zoom, the app bar. It also has a bunch of style sheets that give you the default visuals. So there's a UI light and a UI darks.css style sheet. And you'll use those as the basis of creating your UI. And they give you, a default visual that looks Metro, but you can customize. And they also have some other common infrastructure pieces, things around data binding, things around templating, and so forth that you'll want to take advantage of. I sometimes get the question, is the only JavaScript library I can use WinJS? No. WinJS has this set of capabilities and functionality in it that we think you need in order to build a Metro-style app, but you can use it in addition to, and it is designed to work well with, other JavaScript libraries. So if you're using any other JavaScript library, you can continue to use that in tandem with WinJS. And then finally, there's the Windows runtime. And the Windows runtime gives you the APIs you need to seamlessly integrate with the Metro-style shell. So for example, on that start screen, there are those tiles and notifications that come up. So all the APIs you need to connect up to those things are part of the Windows runtime. If you remember from the keynote, there are demos where you had contracts like the share contract and the search contract and the picker contract. Those are all exposed through Windows runtime APIs, so you can call those APIs to do that kind of interchange between applications and so forth. And finally, the Windows runtime just gives you access to storage, devices, and other kind of capabilities of the PC. So if you want to write files to the hard disk, if you want to talk to sensors on the computer, all sorts of things like that are available to you through the Windows runtime APIs. And so together, to create the UI of your app, you're going to call these three families of APIs. The HTML, CSS APIs, the WinJS APIs, and the Windows runtime APIs. And let's go look at a demo of that in action. And what I'm going to do, actually, is I'm going to pop up the VS default template. So if you go to VS and you say New Project, and you say New Grid App in JavaScript, this is the app you get up here. And I just pulled it up, said the source code over here. And I want to point out some of the things you'll see in the source code just to kind of connect those API families that I talked to you about. So some of the function calls you'll see start with WinJS, WinJS.application, WinJS.navigation. Every time you see an API call that starts with WinJS something, it's one of the APIs that are in WinJS. Okay, that's how you can identify the WinJS APIs. Every time you see an API that starts with Windows something, for example, Windows.application mode, that is one of the Windows RT APIs, so one of the Windows runtime APIs. So if you see an API that starts with WinJS something, it's in WinJS. If you see an API that starts with Windows something, it's in the Windows runtime. It's that simple. And then you all know all the standard JavaScript APIs and all the standard HTML DOM APIs, like set attribute and get attribute and add event listener and so forth. So those are all just the standard HTML, CSS APIs as well. So if you look through the templates and all the code you write, all the API calls you'll be making are either one of the standard JavaScript or HTML, CSS APIs, one of the WinJS ones, or one of the Windows RT ones. All right. Now let's look at, what else do I want to show? Yeah, and let's look at this navigator.js file. It's another file in there. And I just want to use this to point out the kinds of APIs you can expect to find in each of these different libraries. So if you look at these APIs here, there's the Windows UI View Management Application View. This is the API you use to know if your application, what state it's in. Is it snapped? Is it full screen? What's the state of the application? That's an example of something you'll use WinRT to get access to in building your UI. Another thing is Windows Graphics Display properties. This is the resolution and DPI and all that kind of stuff about the machine. That's also from the Windows runtime. You get that kind of information. In WinJS, you see things like navigation, UI, utilities. Those are some of the kinds of things you'll find in WinJS. All right. And now I want to talk a little bit about how WinJS is referenced, because I get questions about this. And so, as you can see, WinJS is just a set of JavaScript and CSS files. And so you reference it just how you'd expect to reference a JavaScript or CSS file. You link hrefit or you script source, include it. But if you look at the URL that's used, see how it starts with a //? So you see that // there? What's going on here? WinJS, the way we've decided to deploy that to you or make that available to you is actually what we call a framework package. So instead of giving you the loose CSS and JS files that you like just copy into your application itself, you actually do it by reference, almost like a DLL. So you reference WinJS. And so if you look here in VS on the side here, you'll see references. And under references, you see Windows Library for JavaScript. And if you expand that, you see the actual JS and CSS files that comprise it. And by doing it by reference, it gives you two advantages. The first one is, very frankly, we can fix bugs, and then you have those bugs fixed. Right? So if you just had statically linked copies of the files, if we were to fix a bug, you wouldn't get that bug fix. And so because it's done by reference, whenever we fix bugs, you automatically get those bug fixes. And then we did want to make sure, though, that there's ways for you to explicitly be in control of which version you're using. And so if you look at the way it's referenced here, you see there's a certain version number that's assigned to it there. So Microsoft.WinJS.1.0.rc. Whenever we make a big set of changes to WinJS, enough that we consider really breaking API changes, we actually change the named version. So if any of you guys tried with a developer preview build, you'd see it was Microsoft.WinJS.0.6. And with the release preview, it was Microsoft.WinJS.1.0.rc. And for the final RTM version, it'll just be version 1.0. Okay, so the version name there, you can explicitly pick the one that you're referencing. But minor bug fixes that we do along the way, you just kind of get automatically by free using the reference. And if you use the templates, everything is set up kind of by default for you the right way. But that's kind of how you reference and use WinJS. But it's totally transparent to you. So you can open up these files, and you can actually look at all the source code of it. And when you're debugging, you can step in there with a debugger and so forth. All right? And this is all part of the grid template. I don't know if I ever ran it for you, but this is just how the grid template looks. It kind of gives you by default a list view, and you can click on things and get into subsections, and you can go back, and it just gives you a general scaffolding, a basic skeleton of an application. It doesn't have semantic zoom, it doesn't have app bar, it doesn't have every feature. It just has a very basic skeleton you can use as a starting point. And so I kind of encourage you to do that. So that's kind of a quick overview of the platform. We just kind of looked at that template. We saw how we made function calls into HTML and CSS, into WinJS, into the Windows runtime from that. For the rest of today's talk, I'm really going to focus on WinJS and HTML and CSS and the new features that we've made available there for you. And there's actually quite a few that we're going to talk about. Under WinJS, I'm going to talk about pages, the animation library, the style sheets, something called promises, binding, list view, and app bar. That's not every feature in WinJS, but just some highlights for you to be aware of that I think you'll want to know. And then under HTML and CSS, we're going to talk about CSS layout capabilities we've added, CSS transforms and animations, the HTML pointer APIs, you use these to do touch, CSS scroll views, and just HTML controls and the enhancements that have gone on there. So let's get started. So CSS layouts. One of the most common things about all these metro-style apps is you open them up and they have this kind of immersive look to them. They take up the full screen. If you have a bigger screen, a smaller screen, a tablet-sized screen, the UI has to scale to all these screens if you rotate, if you snap the app. And so we added a bunch of CSS layout features to help you do this in a very performant way, because users want it to be fast, and we want it to be easy for you to actually code to all these different sizes and form factors you have to use to handle all these things. And so we've added to CSS in Windows 8 a bunch of features called grid, flexbox, multi-column, and also some more media queries. And I'm going to demonstrate a number of these for you right now. And these are basically enhanced layout capabilities that are built right into CSS. And so you don't have to write JavaScript code. Like once upon a time, you had to write JavaScript code to do a grid layout, with absolute positioning, for example, or to do multi-column stuff. And with the CSS features, you just use CSS, and it's all done for you by the layout engine. So let's go switch to a demo of that right now. All right, we're done with this one. I want to point out all the demos I'll be doing today. We had the team write up these different samples to use for the talk, and we've actually posted all of them on MSDN. So if you go to the MSDN sample gallery, every single piece of code I show you, you'll be able to download and start playing with yourself and walk through yourself, so that there's nothing I'm doing that you can't just go download and take advantage of and look at in more depth. So here's this app. I'm going to run it in the simulator so you can see the layout capabilities in action. And basically, what this app did here is it just did a very simple kind of grid-like layout of some content. Okay, once upon a time, like a decade ago, you might have used a table or something in HTML to do this. And it kind of lays out the content. You see a big weather forecast. There's some more information about the weather below, and there's kind of space for an image. And let's see what happens if I make this rotate this UI. you'll see that they moved it so that the image is now below that information, okay? So that data information is now above, whereas before it was on the side, all right? So let's talk about how the app author did this in this app here. And I'm going to show two features, CSS Grid and CSS Media Query enhancements. So CSS Grid is basically a set of CSS extensions that allow you to define a table with cells, the columns, the rows, and span them, and all that sorts of stuff that you want to do. And you do it all in CSS. And so then for every single element, you can say, oh, this is in column 1, row 1, and so forth, kind of how you can imagine that would work. And then the other thing I want to show is these media queries. So that's the CSS Grid. Now here's media queries. If you've ever used media queries, you know they're a way to group together a bunch of CSS selectors so that all of them get applied at once. And so here we have a media query defined that is run when you have full screen landscape. Okay? So media query, MS view state, full screen landscape. So that's kind of oriented like this, wide. If I collapse this, you'll see there's another one for MS view state full screen portrait. Okay? So we defined two media queries in our CSS file. One was for the landscape, one was for the portrait orientation. And inside that, we had all these different selectors for all the different divs that comprised that UI. And so let's look at one in particular. There was a certain aspect, there's a certain dude in the UI where it said feels like temperature. It said, oh, it feels like 48 degrees. Okay, you saw that was one of the strings in the UI there. In the landscape orientation, that was in MS Grid column 1, MS Grid row 4. Okay? But if I go down to the portrait orientation, that same thing was in column 3, row 3. Okay? And so remember when I rotated that UI, the elements kind of rearranged themselves? As a developer, I didn't have to write a single line of JavaScript code to do that. All that was done entirely just by saying, here's the CSS media query I want to use in the layout, in this layout. Here's the CSS media query I want to use in this other orientation. And because I changed the CSS grid column and row properties, automatically when it switched, it just rearranged those same elements. Okay? So it's very easy to create UIs that are dynamic and respond to different layouts and so forth using CSS grid, CSS flexbox, the media queries, and so forth. So this is just a taste of it. This is a big sample. There's a lot of other stuff in here. But I wanted to kind of point out CSS layouts. This is something you should look into and take advantage of to create these apps that take up the screen and work on all these screen sizes and so forth. There's a lot to them. All right, so the second thing I want to talk about after you lay out your app is how the navigation works. Because I showed how all the navigation was inline. There weren't pop-up windows. It was all done inline. And it was all done as a single page application. Okay? And that means that the same DOM, the same objects you had in memory were still in memory. So as you navigate around, you can have smooth animations of pages coming in and various things like that that you saw. And so that's done using WinJS pages. Metro-style apps have this kind of fast and fluid inline navigation. And what WinJS pages let you do is they let you load and unload chunks of HTML, CSS, and JavaScript all as one. So you can imagine you defined a whole web page, and you kind of loaded it in inline directly inside a bigger page. Okay? And that allows you to create these UIs where it feels like you're navigating around in line, but actually you're all always within one parent web page. And the WinJS pages support dynamic content inside of them, as you'll see in this demonstration. So you can have other WinJS controls or other kind of live content inside them that will get invoked and start running immediately as soon as the page is loaded. So let's switch to the demo box and take a look at WinJS pages. Let me, I don't need this emulator anymore. All right, so here's this sample here. So in this sample here, everything you see inside those dotted lines, these are actually all separate HTML pages, okay? This is an HTML page. Here's another one. And they're all just loaded dynamically inside of this bigger page. So there's a bigger page, and we loaded these smaller pages inside of them. And that would allow us to, on the fly, replace them, update them, get rid of them, insert them, and so forth. You can see they're fully interactive, so they have buttons. Here it has a toggle switch, which is a WinJS control, and it all got loaded kind of automatically. Let's look at the code behind this to see what's going on. All right. So on that page, you see here it says, this page is rendered via call to WinJS UI pages render. So let's look at our HTML file. If we look at our HTML file, we say, this control is rendered via call to WinJS HTML UI pages render. And underneath it, all you see is this div. Okay? So all I put is this div on my actual parent HTML page, but it got rendered as this whole thing. How did that happen? Well, I put the div in there, and I put a class on it, whatever I wanted to call that class. In this case, I called it rendering page controls. Then in my JavaScript code, I selected that element, so I selected that div, and then I called this function called WinJS UI pages.render. And with WinJS UI pages.render, I just take an HTML page, and I take that div that I wanted to kind of render the page into, basically, and I call this function, and it does that. And I can also pass parameters to it. So in this case, I wanted to pass some control text and a message into that page. So I could have that page, load it dynamically, pass some information to it, and then the UI kind of renders it dynamically. And I want to kind of show what is this page here? So pages sample page control. That's just another file inside my HTML here. The pages sample page control. Here we go. It's under pages. And if I open that one up, you see it's just a regular HTML page. So there's nothing fancy about it. It's just a regular HTML page that on the fly dynamically was able to load right into place there. It was referencing in turn some CSS and some JavaScript. And so then that CSS and that JavaScript also got loaded and run dynamically. And in fact, you can see, here's that CSS where it said to put that border that's dashed. If I go and I go background color red, for example, and I kill and reload the sample here, you'll see that the pages are red now. Okay? It wasn't that CSS of that parent page got changed. It was that page that I loaded in there. It brought in that CSS with it for its own page. In this case here, this sample loads the page 4 different times. And each time it loads it, it passes some different parameters to it. So you can see that I passed this string here, for example. This control is rendered by this thing here. But I could have passed something else here. I could have passed foo. Okay? And if I do that, you'll see that it says foo there. Because that child page that I passed it to, it was taking those parameters that were passed to the page, and it decided to use them in its own code to fill in the page content like that. So you can kind of do templating and that sort of stuff using the WinJS pages. All right? So those are WinJS pages. That's a quick kind of sneak peek at them. There's a lot more to them. But that's an important aspect of building a Metro-style app, is having this inline navigation. And the WinJS pages really helps you do that very easily and construct an app that is tons and tons of HTML pages for all the different sections and screens in the app, but they're all kind of linked together very easily. So we talked about laying out the app and the CSS layouts and loading these pages of content. But one of the things I showed you in those apps at the beginning was how everything was smoothly animating. So when you went to that article in WordPress, it kind of smoothly came in. When we deleted that message in Mail, it kind of had that cool animation. So how do we do those animations, and how do we do them in a way that's fast and fluid? Well, to do that, we added CSS transforms and animations to the HTML engine. And so these are a bunch of CSS capabilities that allow you to apply 2D transforms and 3D transforms and to do those over time to things. And the benefit of using the CSS animations is that they're independent off the UI thread, and so they're composed in a way that doesn't kind of interfere with or block your UI thread at all. So they'll be very smooth, fast, and fluid all the time, regardless of the other processing going on in your application. And that's one of our kind of principles of Metro-style UI, is that it's fast and fluid. So let's go and take a look at this sample. And we'll run this. And this shows off just some of the capabilities. So in this scenario here, I have 2 balls that are being animated. The top one is being done using traditional JavaScript animations. So literally there's a timeout loop, and it's just move, 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 move. Okay? The bottom ball, the green ball, is using CSS animations. And you'll see that if I increase the amount of work going on the UI thread, all of a sudden the red one becomes very choppy, but the green one remains smooth. Because the green one, the CSS animations run independent of whatever's going on in the UI thread. So if you have processing, if you have network calls, if you have users interacting with things and so forth in your UI, you want to use the CSS animations so they won't be blocked. And they're very powerful. So you can do all sorts of kind of fading transitions. You can do rotates. You can do all sorts of 2D transforms you can imagine. You can do all manner of 3D transforms. Here's one. You can this sample lets you play with all the possible parameters. You can even flip things around backwards. You see the backside of them. You can do things in a staggered way. So you can have transition 1 and then transition 2. And you can also connect them up. So you can say, do transition 1, and when that's done, then do transition 2. Okay? So it runs transition 1, and when that's done, it automatically does transition 2. You can even do them dynamically. So I can have transition 2 running, and then I can click this button while it's running and kind of, on the fly add that other animation. Okay? So they're a very, very powerful model for storyboarding, composing, real-time animations in your applications. And let's look at the API for them, because you'll be amazed by how simple it is. So let's talk about how we did that ball moving. The ball moving was very simple. We just said we had that ball. We put animation name move, and we defined a little animation with just 3 keyframes. We said start at translate 0 pixels, halfway there be it translate 400 pixels, 100% of the way there be translate 800 pixels. That was, that's basically it. And then we were able to, in CSS, just define all the other parameters. 2 seconds, use a linear curve, repeat infinitely, keep repeating forever. So it's very easy. Just with some simple CSS, you can define a whole animation like that. And all those other animations I showed kind of with the same sort of thing. And because they're all defined in CSS, you can also, just by applying these styles at runtime in JavaScript, that's how you can control the animations. So those scenarios that I showed where you pressed buttons and various things started happening, that's just, in your JavaScript code, you just apply those, you define those styles, and then you just apply them in your JavaScript code to kind of have the animation start. And then you can remove the style to have the animation go away. So you define the animations in CSS, and you just apply and remove them in your JavaScript code to dynamically, start them going. All right? So that's CSS animations. It's a very powerful feature we've added to the HTML and CSS engine in Windows 8 that you should use to have these fast and fluid animations that are very important to Metro-style apps. But if you looked at those animations that I showed you there, they're all very simple, and to some degree, they all look like things that a developer might make. But we will have a very specific language of animations in Windows 8 for these Metro-style apps. When you delete things, when a page comes in, when various things happen, we've actually defined a whole language of specific animations that you can use for each of these things that we worked with our designers to create so they all look beautiful and all that kind of stuff. And we've actually making them all available to you in WinJS as the animation library. So there's an animation library in WinJS that has a bunch of predefined animations. In turn, these call those primitives, those CSS primitives, to do the animations. But this gives you kind of an easy language of APIs that you can use to just get very specific animations that we've already defined for you. And let's take a look at those. So here I have a demo of that. This is the WinJS animation library. And so it has a whole bunch of animations, like show page. And so I run this animation, and kind of the page comes in, OK? There's expand and collapse. Expand and collapse. There's another one I like is, let's see if I can find, add and remove from a list. Add, remove, remove. OK? There's a whole bunch of pre-canned animations that we've created for you that you can just call into directly. And let's look at how, and they're customizable as well. So the page load animation, see how it comes in 3 pieces? It kind of looks orchestrated, we say. I can also say, no, just come all at once. And then it all comes in one piece. So there's a lot of configuration you can do of each of these animations. And let's look at how that's done. It's really very simple. You just call WinJS UI animation enter page. And then you just pass it the div or the element you want to animate in, and then it runs that animation on it. Okay? So that's a very simple thing to do. And all the animations are like this. You just call this function, you pass it the divs that you want to have animated, and it animates them. And there's some other parameters you can pass. So when we wanted to do that in 2 pieces or in 3 pieces, we just split up and pass kind of an array of the elements in an array like this. And then the API knew to animate them kind of in a staggered way. So instead of in one big piece, it put it in 2 different pieces or in 3 different pieces. Okay? So with the WinJS animation library, has a whole bunch of these animations. You can just go use them. And all of them, in turn, use the CSS capabilities we built, so they're all fast and fluid. All right. That's WinJS animation library. OK, so we've talked about a lot already, and we still have a lot to talk about. So we talked about laying out your application. We talked about navigating through it and how you animate stuff. Now let's talk about interacting with it. OK? Well, when we were designing Windows 8, we said, hey, we have to let people interact with their applications not just with touch, but with mouse, with pen, with keyboard, and with touch. And so when we thought about the right way to create the APIs for that, we decided to define something called the pointer APIs. And so in HTML, we've added these pointer APIs that give you a single unified API that you can use to access all raw input. So whether someone's using the mouse, or they're using touch, or they're using the pen, you all use the same pointer APIs to get that information and know when did they click, when did they push down, when did they push up, when did they move, and so forth. In addition, we have a common set of gesture APIs you can use. And again, those work across all the input devices, all the input types. These APIs are very rich, and they support multiple simultaneous contacts, as I'll show you. So you can have multiple fingers at once. You can have a finger and a mouse at the same time. You can do every combination of things you can imagine. And these give you all the raw kind of events and the gestures for them. And so let's go take a look at that. This is one of my favorite samples, by the way, the pointer and gesture sample. So here, there's kind of a little board, and there's various pieces, and I can move them around with my fingers. I can move them around with the mouse, and if you have a pen, a stylus on your computer, I can move them around with the stylus as well. And I can do these things in concert, so I can have one mouse and my finger. I can have two fingers and my mouse. With my fingers, I can do more things, of course. I can grab things and rotate them and do that sort of stuff. There's also some gestures, like a hold gesture. So if I press and I hold, if I double tap, it's like double click, it'll do something. It changes the color. Okay, so there's gestures, there's touch, there's mouse, there's kind of all these capabilities. And let's look at the basic API of that. This is a pretty sophisticated sample, so there's a lot of code here. So I'm not going to go through all the code of the sample, but I do want to point out a few things. The key thing I want to point out is that the events you're going to be listening to are these MS pointer events. So you might have in the past listened to mouse events, mouse down, mouse up, mouse move, etc. To write a great Metro-style apps, you actually want to switch over to not use those and instead be using the pointer events. And these work with touch, mouse, pen, etc. And they're kind of the new unified way to do that. There's pointer down, pointer up, and then pointer cancel. So pointer down, as you can imagine, someone put the finger down. Multiple of these might start at the same time. Pointer up, they lifted the finger or the mouse or the pen. And then pointer cancel is something happened that caused that operation to be canceled. Maybe another window came up. Maybe some other thing happened in the system that kind of, the user didn't necessarily lift their finger, it just kind of got canceled out. Okay, that's what that means. And so these are the core events you'll listen to. And then you can also set up a gesture recognizer object on things. And then you can start listening to the gesture events. You kind of feed the gesture object those pointer events as they come in, and then you'll get back gesture events. The gesture changed. It was a tap gesture. It was a hold gesture, etc. And then in your code, you write event listeners basically for these different gestures to do things like move the objects around or make them change color or whatever it is that you've decided to do with those gestures. And the one other thing I'll highlight in the API set here is that there's this pointer type. And so often, you just want mouse, touch, and pen to do the same thing. And so in that case, you can kind of ignore the pointer type. You don't have to pay attention to it. But if you do want to differentiate, if you do want to know, oh, was it with the pen, or was it with the mouse, or was it with the keyboard, the pointer type is what you can use to figure that out. So that you can differentiate if you have to have pen do one thing and mouse do something else, for example. All right? So that's the HTML pointer APIs. All right. Well, that's great. So we have this layout and this navigating and these animations, and we're starting to listen to touch stuff. But a very common thing you're going to do with touch a lot is just have scrolling regions, scrolling, panning, zooming regions. And so to do that in a really good way, we actually extended the CSS overflow APIs and improved our implementation of them to give you all those capabilities built in, because it's a very common thing you want to do. And so if you're just having someone pan through content, you want to use CSS overflow. You don't want to listen to the raw touch and do it yourself. By using CSS overflow, you'll get stick-to-the-finger performance, because we actually process the input on a separate thread from the UI thread, so you have very, very good performance no matter what's going on in the UI, kind of like the parallel to that animation stuff I talked about. You also get a consistent experience, because the CSS overflow has already included inertia, boundary effects, all that kind of stuff, so you have that great experience. It also has the keyboard mouse support as well, so you can use arrow keys and you can use the scroll wheel and all that kind of stuff. And it's very rich. You can support snap points, nesting, chaining of scroll regions, lots of fancy stuff. Let's go look at a sample of that. And this is very common. You'll want to use this a lot in Metro-style applications. You see us using scrolling all over the place as kind of a way to navigate around applications and work with content. So this sample here, someone on my team made. So very, very briefly, here I can pick how I want to pan. So I can pan horizontally. I can make this a vertical scrolling thing. I can make this something that scrolls unrailed. That means you can scroll, any way you want. I can make it something that's scrolled railed. That means that if I start scrolling in one direction, then I can only scroll that direction. If I start scrolling in a different direction, I can only scroll up in that direction. And if I started kind of at an angle, then I can still do, whatever I want. So those are different ways you can configure kind of the experience depending on the UI you're building. There's support for snap points. So here are mandatory snap points. You can see that as I scroll, it'll always be one picture or the other. It's never, half and half. If I leave it in the middle, it always goes to one. There's also support for proximity snap points. That means if I carefully position it, I can still do the middle. But if I just kind of do a big gesture, it'll always end in a picture. Okay, so there's proximity and there's mandatory snap points. There's support for zooming. So you can do all sorts of zooming kind of things. And there's support for very rich control of the objects inside a region. Because sometimes you might have the overall region is panning, but then certain gestures you want to handle yourself within. And so, for example, this overall region is a panning thing, okay? But if I put two fingers here, I want to let this guy grow. Or this overall region is a panning thing, but this one guy here, I want to make him move up and down independently from the rest of the things, right? The same thing, this guy here, up and down, he moves with everything else, but left to right, he moves independently, all right? And I use MS Touch Actions to do that. And so let's go look at the code behind all this to see what's going on here. Well, for starter, all those things I showed you, the horizontal, the vertical, the unrailed, the railed, again, that's all just CSS you configure on the object. Overflow hidden, overflow X, overflow Y. If you want to configure rails or not rails, you just use the MS Scroll Rails none, or MS Scroll Rails is railed. Those snap points is the same thing. It's just a CSS property. CSS, snap points mandatory, snap points proximity. You can define the intervals you want to use. You can use a snap list to define them, so you can define very specific points along the way. It's all done in CSS. The touch action stuff I showed you, that's also in CSS, is how you tell the system which things do you want the system to handle for you and which things do you want to handle. So remember that one where I did the pinching, and if I pinched it, it zoomed up, but otherwise it panned? So that was this one here. Okay? How I did that is I set on it MS Touch Action pan X, pan Y. That means I'm telling Windows, hey, if someone pans X or someone pans Y, you handle it. Otherwise, send me all those MS pointer events. All right? So ordinarily, the system will handle it, but if you use MS Touch Action, you can tell it, oh, no, only handle those. I'll handle the rest myself. And then you write all your own code that listens to those various gestures and so forth. All right, so that's that's the CSS scroll views. Very powerful set of capabilities, very easily exposed to you to have all those kinds of panning experiences that you want to have. That should be familiar to you if you've used Overflow today. Okay, now let's talk about HTML controls. Another area that kind of we've invested in that you want to use for Metro-style apps is controls that are optimized for touch. And so what we did is we took a lot of the standard controls you already know that are part of HTML. Button, input type equals text, select tag, all those standard controls, and we've enhanced them for Windows 8. And we've also implemented some new controls. So for example, input type equals range, progress, new HTML tags basically are now supported as well. And all of these have the right interactions with touch, mouse, and keyboard. And they also have very extensive styling capabilities. So you can use the controls. A lot of people on the web today, if they want to make a button, they just put an image there and they do on-click, for example. It's a very common thing you see people do. But you won't really get all the right interactions with touch if you do that anymore. So you really should use the controls and then style them to have the look that you want so you get all the right interactions and behaviors for Metro-style apps. And we've added all this capability to make that easy for you to do. Let's take a look at that. All right. This is a sample that shows a lot of the HTML control capabilities. I just want to highlight text controls is one. So they've been enhanced, so they have things like these clear buttons in them. They have touch text selection and integration with the touch keyboard built into them. You can style, they have spell checking, so I can go and here I'm going to type on the regular keyboard, this is really special, and I misspelled both those words, and I can spell check them. So there's spell checking built into them. So they've been enhanced with touch text selection and lots of other features. And you can apply all those other features I talked to them. So that CSS transform that I talked about before, you can apply that to an input type equals text. And then it's still the fully interactive text box. This is a test of a text box. Still the fully functional control. But it has spell checking and all those things. But it's just applied with this transform. All right. So that's one example of something. Another one is a select control. That's been enhanced. So you can scroll up or you can scroll down. It works nice with touch. So these nice animations, various things like that. The range control is an example of one of the new controls we've added. Another one is the progress control. So you now have the progress ring and the progress bar and so forth. There's a tag that's built in there. The range control, you can configure it in lots of different ways, up and down, left to right. You can hide tick marks and tooltips. And you can style it extensively. And I want to point that out. So even if you have the same interaction as you get, no matter how it looks, you can style it quite a bit. Let's look at the code about how that styling is done. So in general, range, here we go. So to get a slider control, you just use input type equals range. That's the standard HTML5 tag to use to get a range control, a slider control. But if we want to style it, what we've done is we've added a bunch of pseudo classes, they're called, so that you can use a CSS selector to select each individual part of the control. So in addition to selecting the overall object, for example, that overall styler, so if I go to my initial, here we go, you see that I have input type equals range, ID equals steps. Okay, that's this slider here. We actually were able to select the track. We're actually able to select the thumb of that individually. So the thumb is just the little round thing that moves, for example. So we actually have CSS selectors for every single specific piece of the control. So you can individually style and control every single aspect of the controls. And this gives you a lot of power to have the same interaction, but style them richly. All right? So that's how you can do this kind of stuff. So HTML controls, check those out. And that's you should really take advantage of those to get the right interaction model in your MetroStyle apps, instead of trying to build everything kind of in JavaScript or using images, as you might have in the past. In WinJS, we provided some style sheets. So using those styling capabilities that are in those controls, we've actually provided some style sheets that you can use to create UIs that look MetroStyle by default. And let me pull up a sample that shows you that. These style sheets, we actually give you two of them. One is called UIDark.css, and one is called UILight.css. So if you want a darker background to your app, maybe a picture or something, you might start with a dark style sheet. If you have a lighter background, like white or light gray or something, you can start with a light style sheet. And in either case, you can then customize it beyond that to have your specific look of your app. All the style sheets give you great defaults for high contrast and also for international text. And they're well-defined CSS selectors for every single thing in the UI. So you can just override that one selector to override that one thing in the UI. And let's see how that works really quickly with the sample here. This is it's almost a tool. So this sample shows like a bunch of the controls that we have in the system and basically how they look in the light style sheet and in the dark style sheet by default. So this is the default look of all these different controls. And in addition, text selection, so forth. But it also shows you how you can override the colors of things. So I can, for example, if I wanted to use green, I like the color green. Oops. I can do that, and then all over my UI, all of a sudden things are green. Selecting text, list views, and so forth. And this sample actually spit out the CSS code I have to add to my app to override the defaults. So it still is built on that UI light or UI dark style sheet, but then I've overridden certain colors. Okay, so it's very easy to create UIs that are colorized to your corporations or your businesses or your app's color scheme, but still have that same kind of common look and interaction stuff to them. And that's all because of the style sheets. So you can open them up and you can see these are the UI light and UI dark style sheets. They're huge. They have lots and lots of CSS in them. Like I was saying, they cover high contrast for you by default. So using media queries, you don't have to worry about if users who have vision impairment. If you start with these, they'll get the right look by default when they use high contrast. They also have a lot of fonts built into them by default, so that if you have international text in your UI, Meiro, for example, is a beautiful Japanese font. Every language that we support, we have the font fallback built in for them all, so that if you just start with the style sheets, you'll have a great app that works internationally and with accessibility, as well as kind of the default visuals that you want. All right. WinJS promises. So we laid out our apps, we navigated, we animated, we listened to touch, we plopped some simple controls in there, we styled them. But now let's talk about some more heavy lifting that you're going to do in an application. Because you're going to start having to deal with data, get data off of networks, off of API calls, process data, and so forth. And that's when you want to start paying attention to promises. Promises are a fundamental building block of metro-style applications in HTML and JavaScript that facilitate asynchronous programming patterns. And they're a really important concept to wrap your head around. As you start to use more sophisticated controls or try to do data binding, you really have to understand promises. The idea behind them is that it's very important to us that metro-style apps are fast and fluid and are always responsive. We don't want to have the UI be hung ever or not interactive because something is going on, that you're processing something or getting data from a network or something like that. And so promises are a coding pattern that we built that facilitate asynchronous programming. And the concept of a promise is that if you have a function that's going to take a long time to return, instead of waiting all that time, you return a promise right away to the caller. And on that promise, it's kind of saying, I promise to eventually give you this data. I just don't have it yet. Okay? It's like an IOU. It's like a bond or something. It's like, here you go. Here's this thing right away. And then the person who got that promise back can wait until it actually is materialized to then do something with it. But they get it right away. So they're not blocked. They're not waiting on your function call. And this is actually maps to something you see in a lot of the WinRT APIs also have this asynchronous programming pattern. So using WinJS promises make it really easy to work with the WinRT APIs that have these asynchronous calling patterns. And so let's look at a sample of this and try to wrap our heads around it, even though it's late in the afternoon. It's a really important concept to kind of get. And it's a facility that's built in for you with WinJS. So I'm going to show you the sample, and it's not going to make any sense. And then I'm going to show you the code, and then I'll show you the sample again. Okay? This sample just does a very simple thing. It writes a function that does addition, an add function, but it's a slow add function. It takes time. Pretend it's simulating as if it was a slow network operation or slow CPU operation or storage operation. Okay? And what it's going to do is it's going to add a value to another value. Then it's going to take this return of that, and it's added another value to it. It's going to wait, take the return of that, and add another value to it. Okay? And so the sample is not, super exciting. Just you see, it added something with 3, and it got 1 and 2 to get 3. Then it added 3 and 3 to get 6, and then it added 6 and 4 to get 10. Okay? Very simple what it's doing. Let's look at the code about how this works. So the first thing I'm going to show you is we define this async add function. Okay? This is a slow add function. All this function is really doing is adding, it has num1 and num2. All it really is doing is adding num1 and num2 and then returning that. Okay, that's all it's really doing is adding those two things and returning them, but it's doing it behind a timer. So just to simulate it being slow, we put that whole thing behind a timer of a second. But you'll notice this function doesn't return that value directly after the timer. What it does is it returns a WinJS promise. So see how it says async add return new WinJS promise. And so that WinJS promise has a closure that wraps all this little function that we did here with the timeout and everything is actually wrapped inside a WinJS promise. And so the async add function immediately returns a WinJS promise right away. And then that WinJS promise actually contains the closure that does the actual processing that takes some time. So let's see how we call that function. Well, when someone presses that button that says start the scenario in the sample, it says async add num1, num2, which is 1 and 2. So it adds 1 and 2. And then you see it does this dot then. Okay? So see it's dot then? Because what's going on there? The async add function returned a promise. Every promise on it has a function called then. And then is the function that gets called when the promise is ready to actually return the value that it's worth. Okay? So async add returned this promise right away. On the promise we called dot then. And what did we do on dot then? We took the value that the async add gave us, that's this value v, that was the return value in effect, And we said, well, we just got the value v after adding 1 and 2. Now we're going to add v to 3. And then we're going to call async add on that. Just for fun, we're calling ourselves recursively here. And so then this whole thing here is returning what? It's returning whatever async add v and num2 is. Well, what's that? That's also a promise. Okay? So on this overall function, we call again .then. All right? Because it's another promise. And in that .then, same thing. We say, oh, well, we just called async add and we got back this value after adding these two things. And then we call it again, just for fun. And we say, well, .then, we output kind of that final thing that happened. And then we say done, because we're done. We could have kept going on and on and on forever if we wanted to, but we decided to just chain this 3 times. And then done is how you end that promise chain. So done, promise chain is over. All right? So you might want to spend more time with this, but again, in the end of the day, once you've done this, it's that same thing kind of going on here. The asynchronous add, it ran, it returned that promise right away. The promise completed. Once it was completed, we got the value, we ran some more code, then we did a .then, we waited until we got that actual value realized, ran it again, and so forth. So you'll probably want to play with the WinJS promise sample some more, but they're a very powerful construct, and you can also do things like join them. So maybe you have 2 operations that are both slow, and you want to say, hey, I want you to do this thing only after both these things have done. So you can create a join promise. So maybe one operation takes 2 seconds, one takes 3 seconds. They both run in the background. When they both returned, then we do the .then function. You can also do any. You can take 2 promises and say, as soon as any of these returns, do the next operation. So they're a very powerful construct, and you'll really use these a lot in asynchronously programming your UI so that you never hang the UI thread. All right. So those are WinJS promises, a very important building block and construct for asynchronous, fast and fluid UIs. And they're used by lots of features, including binding. So let's go look at WinJS binding. A lot of the apps are going to have data. All those apps I showed you at the beginning, the Mail app, the WordPress app, the SkyDrive app, all of them were showing you data. Mail data, blog data, RSS data, data from a SkyDrive web service. And they all were binding that data into various templates that you saw in the UI. And so there's a bunch of binding capabilities in WinJS that you can use to do this. We give you one-way binding with asynchronous notification. So as pieces within the data get updated, immediately gets updated in real time. And there's a way to do it programmatically. There's also declarative support, so you can just put certain markup in to get them. And there's support for whole templates. And so there's a lot to binding. I'm not going to be able to demo all of it today. But I'm going to go and show you a few key things there. So let's open up our WinJS binding. Whoops. All right, here we go. So binding, again, the basic concept of it is maybe I have a text box. Hello, everyone. And maybe I have some UI down below. And when I update this, it updates the UI below. So both the text box and the other UI are bound to the same WinJS binding object. You can also bind attributes or other properties on elements. So here, for example, I'm binding the background color style of this element. So it's not just textual data, but even CSS attributes and so forth you can bind. And you can run functions in real time. So here's taking 3 text values, and it's converting them into an RGB value to pass as the background color, right? FF, 0000 or whatever it is that I defined there. Okay? And then you can have full-on templates. So here in HTML, I defined a little template of how I wanted this object to look. And then I bound this whole object to a binding object so that as I update anything else, 111, it updates down there. If I update these colors, it updates down there as well. Okay? And that's for the first object, but I could have another object, 2, 2, 2, etc. So I think you guys get the idea. All right. So let's go look at the code behind this a little bit. So what's going on here? Well, first, in our code, we have to define the WinJS binding object. Okay? So that can be any kind of JSON object, any kind of JavaScript object you can kind of turn into a binding object using the binding define, WinJS binding define. Then I can instantiate multiple instances of that type of object. So here in that template sample, I had those three. Remember those three, the red, the green, and the blue one? Or the one? Here, let me just red again. The red, the green, the blue one. So I created those three objects that are instances of that binding object. Then what I did is I created a template. And so let me show you the template was actually defined in HTML. If I go down to my HTML file, here I have this data win control is WinJS binding template. This is the standard model we use for declarative controls, and the binding template is in effect a control. I'll show you list view and app bar in a second, or two other controls. So by creating this data win control binding template, I was able to in HTML define the actual kind of where I wanted that little tile to look, that little template to look. I was able to define, using the data win bind property, what properties I want to put where. So in this case here I said, hey, I want to bind the background style to the color property. And then I use this template color to CSS color converter. I'll show that in a second. And then inside, if you remember here, I have like this label, and then I have these three values that are all coming from here. So I data win bind the text content to the text property. That's the same as here there's this text property, okay, in the binding object. I bound where it said R, I bound it to the color.R. So data win bind, data win bind the text content to color.R. So here it says R:255. That's being bound to color.R, which is in the binding template right here, color.R. Okay? So in that binding template, I created the binding template object, I instantiated instances of it. Then in my binding template, I used the data win bind attribute to specify which properties from the binding object I want to have mapped kind of to the control UI there. Then I hook it up. Let's see here. Then I hook up the different text controls to change the binding. And I kind of hooked that up there. And then I selected that template. So I query selected that template I defined in HTML. And I picked a div that I wanted to render into. That's just another div on that page. And I just kind of render the template control into that div. All right? So I had the template I defined in HTML. I had the binding I defined in JavaScript with the WinJS binding object. I hooked up my various text controls to whenever I invoke one of those text controls or change their value, it goes and it changes the binding. And then by just rendering that binding template out onto the page, it is always updated in response to the binding template. So that's kind of a quick peek. Like, I'm not going to walk through all the code of the binding because that'll take too long. But that's kind of what you can do with the binding. You should go and look through there. And a couple samples around binding. There's both the programmatic and the declarative model for how you do it. But that shows you a little bit of the capabilities of the things you can do with binding. I'm going to move on, though, in the interest of time. And I think you guys got a good idea about the kinds of things you can do there. And I'll be available later to answer more questions if you guys want to go in more depth on any of these. OK, list view. So the binding template was really useful if you have like one object you're binding to some data. But often you have a whole set of data that you're binding, right? You have a database query result. You have an array of data and so forth. And so for that, a list view is really the common UI pattern you want to use for that. And I showed you those list views with the selection and all those kinds of behaviors. And if you use the list view control, you get all those behaviors, all that experience. It's very common in Metro-style apps for you. You can bind to data of your choice. You can bind to in-memory arrays. You can also you can write your own data source provider and bind to web service data, any data of your choosing. It's fully data virtualized so that we won't load any more data than is necessary to kind of render the UI. There's very rich templating and styling capabilities available. There are a lot of samples we have around the list view because it's a very powerful control. I'm just going to show you the simplest one of those to kind of get you started. If you look online, from the Build conference, we had a whole talk just on list view control, and you can learn even more about the kind of options and things there too. So here's just a simple list view sample. All right, so you can instantiate a list view. and you can have a bunch of templated data here. So I'll show you in a second. All this data is just coming from an array, a JSON array. You can respond to events. So when I click on things, it tells you, oh, you clicked on this item, and here's the data that was there. You can switch between different layout presentations of the same data. You can get and set selection. You can have the user do it, and then you can say, what's selected? Oh, there are 2 items selected now. There's just 1 item selected. You can programmatically set and clear selection, so you can do all that kind of control. This shows you how to rehydrate as well. I won't talk about that for now. So there's a lot of capabilities there. There's also grouping, semantic zoom, lots of other stuff you can do with a list view. Let's look at the code behind this now. And there's just 2 things I really want to show. First, how you instantiate the list view. It's that same kind of data win control syntax you saw before. Data win control, winjs.ui.listView, that kind of plops it into the page there. And then data win options, that's how you pass all the optional parameters you have to the control. And there are 2 very important ones you have to understand. All the other ones you can kind of choose to do or not do, but one of them is the data source and one of them is the item template. So the core of a list view is you have a set of data and you have a template for each item in the data, and it kind of puts them together and presents the data to you. Then there are other options you can do around selection and tap and swipe and so forth. So what is the item data source? Well, it's anything that implements a data source interface, and we've provided a great one for you called winjs.binding.list. And so if I go to this data.js file, you can actually see an instance of that, a winjs.binding.list, and all we do is we pass a JSON array to it. So for every item, it says the title, the text, a picture to associate with it. And then we got back this myData object. Okay, that's just a winjs binding list. And so you can just pass myData.dataSource. That will give you the data source from that winjs binding list to a list view. And then you're kind of all set. That's how you got your data in there. Now, if you wanted to, you can implement your own data source. You don't have to use winjs binding list. That's just a very easy thing you can use. It'll be all in memory. It'll be very fast. You can implement your own data source and learn all about that. If you have to have, paginated data from a SQL query and a web service and all sorts of stuff like that, that's just more work to implement something complete like that. And then we also passed it a template. So here's a small list icon text template. What's that? That is just a WinJS binding template, like I just showed you demoed before. So you pass a template, and we pass that data source, and then the list view takes care of hooking everything up for you. So in that template, I said, oh yeah, I want the picture to go here as the source attribute on this image. I want the title to appear here. I want the text to appear here. Right? Those are the same properties here. You're seeing title, text, picture. And it kind of hooks it all up for you and gives you kind of that whole rich experience around seeing that data, interacting with it, selecting it, and so forth. Okay? So that's the list view very simply there. And you can add event listeners for all the different kinds of get selection and so forth. It's kind of all the APIs in the kind of way you'd expect. So that's the list view. And that's a very important control you'll want to use. And then finally, the last thing I'm going to talk to you about in detail is the app bar. It's also controlled in WinJS. It's also an important part of making Metro-style apps. You see this all the time. It gives you a common UI for presenting commands, for having it come up and invoke itself with the swipe and with light dismiss. It works with touch and mouse and keyboard and all those things you know about. It's positioned based on the system context. I talk a lot more detail about the UI of it in the talk I gave this morning. You can watch the video for that. But let's just look at the code behind it now. All right, here's the sample on this. So the app bar, again, pops up from the bottom. You can color it, of course. You have buttons in it. You can position the buttons on the right or on the left. If they're contextual commands, they go on the left. If they're global commands, they go on the right. You can have separators. You can customize them so you can have it change from play to pause, for example. So you see how the icon changes. It's a very flexible control. You can programmatically have it change commands. You can have it show and hide programmatically. By default, it'll come up just by the user swiping from the edge of the screen. And so forth. There's lots of capabilities that it has. Let's just look at how you program to that very, very quickly. Again, it's a data win control, WinJS UI app bar. So that's how you kind of instantiate it there. You could have passed options. I don't have any options in this case. And then for the buttons inside of it, again, I use the button control. And then each of those, I say data win control, WinJS UI app bar commands. And then I pass some options to that. What do I want the ID of that command to be? How should it be labeled? what icon should I use? We provide a whole set of icons built in for you that you can use. So you don't have to create your own icons. There's a whole bunch of them right there for you. Do I want it in the global section, or do I want it in the contextual section on the side? There's also support for separators. So here you see a HR tag, horizontal rule, but it's configured to be an AppR separator. Okay? So that's kind of how you can configure it. And then you can basically listen to event listeners on it. So you get that command add, for example, and you add an event listener to it to handle the add event. So remember in the sample, I had an add button. Here we go. Every time it was clicked, all I did is on that button control, I added an event listener for on click, and that's how I knew it got clicked. So it's the same kind of programming model you're familiar with HTML, but the control adds that extra infrastructure of how it shows up and how it makes things look that give you that kind of familiar feel of metro-style apps. All right, so that's the app bar control. So just to wrap up, we've covered a lot of stuff today. We talked about the overall platform for metro-style apps using HTML and JavaScript. We talked about a bunch of, not all, but a bunch of the features of WinJS that you really need to know about to use to make these apps. We talked about a bunch of the features that are added to HTML and CSS that you need to know to use to make these apps that have this look and feel. We talked about how HTML has this powerful presentation model, lets you reuse all the skills and code libraries and tools that you're already using, and it's been enhanced for you for Windows 8. We talked about the library for JavaScript that has all these controls in it, these style sheets, and these other UI building blocks like binding and promises that are important to make these asynchronous, responsive, fast and fluid apps that are metro style. We mentioned that Windows Runtime is the other part of the API set that you can go to John Lamb's talk and other talks to learn about. So that's the platform for metro style apps with HTML and JavaScript. Thanks very much for your time. I know it's the last session. So thank you. Hope you had a good TechEd. I'll hang around here if you guys have any more questions, and please fill in session feedback and stuff like that. Thank you very much.